In this video, we will practice graphing sine and cosine functions with changes in the amplitude, the period, and phase shift, and also some reflections over the y-axis and reflections over the y-axis. I should be pointing at this one, and reflections over the x-axis. Okay, you will hear me referring to the the a value, the b value, and the phase shift, and any vertical shift. So these are the things I'm talking about when I talk about a value, b value, etc. So on problem number 21, the a value goes right here. There is no visible a value, which tells you that the amplitude must be 1. Now, there is going to be a b value. Normally the b value is going to go right here outside the parentheses. Now we're going to have to do something special with this because this 2 is going to turn out to be the b value, but we are going to have to factor this out. We really need this 2 to be outside the parentheses to reveal what the actual phase shift is. So I'm going to come back to that. We're going to have to change the form around a little bit. But we do have this k value. This is going to be a vertical shift, so things are going to move up 1. All right, so we're going to deal with all of that. All right, to show you how to rewrite this equation properly, we need to do a little background discussion. I could factor this using the common factor. So I see that there's a common factor of 2. So I could bring this 2 outside of parentheses, and I would have x plus 3. Now this was very obvious, but sometimes I say things like this. Hey guys, if I want to know what goes inside the parentheses, I will take this common factor and divide with it. So that gives me the x plus 3 that goes on the inside right here. Now, thinking of it that way will help me understand what to do if I wind up with numbers that are not so obvious. So imagine that instead of 2x plus 6, what if I had, let's say, 2x plus 7? But let's say for some reason I still really wanted to pull that 2 outside of the parentheses. I could, even though it's not a common factor, I could pull it out as long as I use the same procedure that I did over here. When I pulled out the 2, I divided everything by 2, and that's what told me what to go on the inside. So if I'm going to pull out a 2, I still need to do that. I'm going to divide both of these by 2, and that tells me what will go here. So these 2's will still cancel, and I will have x. But for this, I have no choice but to just leave it as 7 over 2 like that. Okay, now that you understand that, we are ready to talk about rewriting this equation. So if I have 2x minus pi, okay, so if I have 2x minus pi, if I really want to pull out that 2, I can. All right, as long as, just like I did on the previous 2 examples, I divide each of these by 2. So if I divide by 2 here and I divide by 2 here, what is that going to give me? So that is going to give me x minus pi over 2. So guess what, guys? This is the form that you have to write the problem in before you can start talking about what the phase shift is. It has to be in this form with the b value factored out. All right, so if you have a b value, you have to factor it out before you talk about the phase shift. Okay, so going back to this problem, I had to rewrite it. So this problem becomes, hold on. I need to write with finer ink. So this problem becomes y equals the sine of. Now I'm factoring this 2 out. So I'm going to have that 2, and then I'm going to have x minus pi over 2. And then plus 1. All right, so I just did just what I showed you. I pulled out the 2, but then I had to divide by 2. So now we can talk about the period and the phase shift. So this 2 right here is the b value, and that's going to indirectly tell me the period. So remember, the period is always 2 pi divided by the b value. That means the period is going to be 2 pi divided by 2. So the period will be pi. So, okay, so I know the period will be pi. Now that I have factored out the b value, as I must, I can see that the phase shift is not pi, but rather pi over 2. So the phase shift is going to be pi over 2. And because it's minus, it will actually be to the right. So the phase shift is pi over 2 to the right. And now I am able to sketch the graph. This plus 1 over here on the end is going to be a vertical shift of up 1. Okay, so let's see how it goes. Okay, so here's my x-axis. Here's my y-axis. The amplitude is just 1, so it's going to be up 1 and down to -1. The period is pi. So I'm going to come way over here and I'm going to put pi because that's the period. Half of that I'm going to put pi over 2. Half of that I'm going to put pi over 4. Now halfway between these, this is the third position, so it should be 3 of these. So this will be 3 pi over 4. Now, if there was no phase shift, let's talk about what the graph would look like. Well, hold on now, let's not be too hasty. Let's not forget about the plus 1 on the end that tells us that we need to shift everything up 1. That means the midline will not be the x-axis anymore. The midline is actually going to be up here at 1. So let's go ahead and draw a dotted line up at 1 representing the new midline. Alright, now if that's the midline, I'm going to need more space above. Okay, so let me go ahead and extend this line further up. So if this is the midline, right, remember the amplitude is 1. So it's going to have to go up 1 from here. So I'll put another mark up here at 2. Now, so instead of looking at the x-axis, focus your eyes on the midline as we draw the picture. Now there is a phase shift coming, but that doesn't come until the end. So let's ignore the phase shift and graph what it would look like without the phase shift. So this is the sine function. So the sine function starts off at the midline, and then it goes up from there, and then it goes back to the midline, and then it goes down to its lowest point, and then back to the midline. That is one period. And see how it ends at pi? Well, that makes sense because for this problem the period is pi. Now, this is what the graph would look like if there was no phase shift. However, there is a phase shift of pi over 2 to the right. Now, as I do this phase shift of pi over 2 to the right, notice that pi over 2 is a value that is on my number line. that makes it easier to see that pi over 2 is this many. Pi over 2 is this distance. It is 2 jumps. It is 2 sections of this graph is pi over 2. So when I shift these points to the right by pi over 2, I am shifting them to the right by 2 spaces on this axis. So just keep that in mind. So let's move the very first point, and then we should be able to graph the other 4 points just by using the pattern. So this first point will shift from here on the y-axis over these 2 spaces to the right, and it will land here. Alright, I've moved this point over to here. Now the rest should just follow the pattern of the sine function. Okay, so from my brand new point that's been shifted over to the right, I'm going to follow the sine function pattern, which goes up to its highest value, back to the midline, down to its lowest value, and back to the midline. So this is the final graph of the sine function after all of the transformations are done. Okay, and just one more time for emphasis, please understand that what we did was we took this initial value and we shifted it over pi over 2 to the right. And we did that for every point. So for example, this point up here at the top of this hill corresponds to this point over here. Just everything shifted over pi over 2. Alright, so that was the final answer for number 21. Okay, number 22. This negative sign right here is going to be a reflection over the x-axis. So let me just make a note of that. This is going to be a reflection over the x-axis. Bam. Okay, however, the a value is negative 1, so the amplitude is still going to be 1. Now the b value is going to end up being this 3. But before I judge the period and the phase shift, I really need to rewrite this function. So I cannot leave it as 3x plus pi. I must factor out the 3 outside of parentheses, like this. Okay? And that's allowed as long as I take this 3 and I divide by 3 in both places. So these 3's will cancel out, and that will give me x plus, and then in here I will have pi over 3. So 3x plus pi is the same thing as 3 times parentheses x plus pi over 3. This is the form that you must use before you start talking about the phase shift. So as I rewrite this equation in the new way, I will think of it this way. Y is equal to negative cosine, but then I'm going to have 3 times x plus pi over 3 like I just said. And then I still have this minus 2. Alright, I have to rewrite it like this. So now I can talk about the period and the phase shift. The period is going to come from this b value, which is right here. Okay, that is my b value. And but the way I get the period is I do 2 pi divided by that b value. So my period is going to be 2 pi divided by 3. So that's the period. It should be 2 pi over 3. Now the phase shift is going to come from this right here. But it's the opposite of what you would think. So I am going to have a phase shift of pi over 3. But a plus pi over 3 is actually a phase shift to the left. Okay? And then this negative 2 on the end means the graph will be shifted down 2. This should be enough information for me to draw the graph. Let's see. It's going to be to the left, so I'm going to leave a little extra space to the left. All right, so here I go. Here comes my graph. Okay, so let's see. I'm going to leave a little extra space on the left. So here's my y-axis. Now, I made this a little extra long because the whole graph needs to be shifted down 2. Okay, so if this is 0, I'm going to have to shift everything down 2. So it's going to be like this. So negative 1. So this will be negative 1, and this will be negative 2. I'm going to put another mark down here at negative 3. But the negative 2, that's the midline. So I'm going to draw a dotted line through here at negative 2, because that's going to be the brand new midline of this function. Okay, so instead of the x-axis, I'm going to be focusing my eyeballs on the midline at negative 2. Now, this is a cosine function. Oh, let's do the period. The period is 2 pi over 3. Okay, so I'm going to come way over here and I'm going to put 2 pi over 3. All right, the end of my period. Now if I go halfway, if this is 2 pi over 3, this should be 1 pi over 3. And half of that should be pi over 6. Okay, and the third position should be 3 of these. So this should be 3 pi over 6. But doesn't that reduce down to pi over 2? Because 3 goes into 6 twice and makes pi over 2. Okay. Now, let's talk about what the graph would look like if there was no reflection over the x-axis and if there was no phase shift. Now, normally cosine starts off high. So normally cosine would start off high and then it would go down from there. Because there is a reflection over the x-axis, instead of starting off high, the cosine function is going to start off low. So it will start off low and then go to the midline and then go up to its highest point and then fall back to the midline and then end up low. All right, I've turned it upside down because of this reflection over the x-axis, the negative sign in the front. But what I haven't done yet is I have not dealt with the phase shift. So this is what the graph will look like. I've moved everything down by 2. I've done the reflection over the x-axis. But now I need to move everything pi over 3 to the left. Now look, pi over 3 is already visible here on my graph. So please notice that pi over 3 is 2 of these. All right, can you see that? This is a distance of pi over 3. It's 2 marks. All right, so that makes things a little bit easier because when I do my phase shift, left pi over 3, I need to go 2 of these to the left. So that's going to make it easier than it sometimes is. So let me make this a little bit longer. So I'm going to move everything 2 marks to the left. So like here's one, here's another one. So one mark to the left here, of course, would be negative pi over 6, all right, if this is positive pi over 6. If this is positive pi over 3, this should be negative pi over 3. So this is going to be relatively easy because all I have to do is move each one of these to the left by 2 jumps. So this point, if I move it over to the left 2 positions, should be here. Now really I can just go ahead and follow the cosine pattern now. So if I'm going low, then it's going to go back to the midline, and then it's going to be at its highest point, and then it's going to go back to the midline, and then it will be at its lowest point again. So this is what the final graph should look like. Okay, notice one more time that all I did was I took each one of these points and I moved it to the left like this by pi over 3. And I noticed that pi over 3 has a width of 2 of these marks. So each one of these points, like this point here at the end, 2 jumps to the left, and that's what happened. All right, that is it for problem number 22.